Next important idea in 5.3 is the idea of the average value of a function. So think back, we talked about computing average velocity. That's the distance you travel divided by how long it took you to get there. And then we learned that distance traveled could be found by the area under the curve. So check out this expression. This is average velocity over the interval a to b. And that's the area under the velocity curve from a to b, distance traveled, divided by the change in time, which is b minus a. And it turns out this is such an important idea. It applies to other kinds of functions too, not just velocity functions. And when I get you your next blue paper, there are two new important ideas for semester 2. One of them is adding in this definition to your paper. So, critical definition right here, the average value of a function f of x over the interval a to b is 1 over b minus a times the integral from a to b of f of x dx. I promise you this is going to be on your test in at least 4 or 5 different places. Your actual AP test in May. So it's just something to think about. If we talked about your average test score, right, you know how to compute that. You'd add up all your test scores and divide by the number of tests you took. And that works because you take a finite number of tests. But now if I want to talk about the average value of a function has infinitely many x values that you can evaluate it at. So that's why we have to use the integral to do all the adding up of. And then the 1 over b minus a, that's dividing by the essentially the number of x values that you divided by. And just think about this. If I asked you to look at somebody's test scores and to guess their average test value, you could compute it. But if I just asked you to guess, you would know for 100% certain that their average test score was less than their highest test score and bigger than their lowest test score. So that's something I want you to keep in mind of when you check your answers to average value problems. Make sure that if you state an average value, your final answer is smaller than the biggest value and bigger than the smallest values. And take a look at this next problem. Okay, here, imagine that I have a piece of wire and here's a heat source at the one end of the wire, and it heats the wire, but it doesn't have as much effect far away. So I can measure the temperature along the wire, and near the heat source it's going to be really hot, and near the other end it's not going to be as hot. So that function, they've told us, is called T of x, the temperature of the wire, and it's measured in degrees Celsius. So we've been asked to write an expression in terms of T of x for the average temperature of the wire. Well, the average value of f of x over a to b is 1 over b minus a times the integral from a to b of f of x. The average temperature, given that temperature in this problem is called T of x, is going to be 1 over, what are a and b in this problem? Well, the wire is 8 centimeters long, so it starts at 0 distance from the heat source and goes to 8. This is 1 over 8 minus 0 times the integral from 0 to 8 of T of x dx. So that's the first answer they've asked for. That's your expression. That's worth 1 point.